Hi friends. So today I am starting another new chapter in second year physics, that is very interesting one, alternating current. Alternating current. See, from this chapter hardly you will be getting 1 to 2 marks in MSET. Hardly you will be getting 1 to 2 marks in MSET. Okay. Now let us start the chapter. This is the 9th chapter in your senior intermediate physics. Okay. Now what is alternating current? What is the difference between alternating current and direct current? What is the definition? Alternating current means generally in the household purpose we are getting alternating current. Okay? That means continuously the direction is changed. Up and down, up and down. That means you can see alternating current, you can go like this. This is the graph for AC, alternating current. If you observe carefully, plus minus, plus minus, plus minus. This is a sine curve, sinusoidal curve. So what is happening here? The direction is continually changing. Plus, minus, plus, minus, plus, minus. So this may be any form. In a formula number so. It may be square, rectangle. Okay? It may be any form, you can see. So this is a square type. Square type. You can see plus, minus, plus, minus, plus, minus, plus, minus. It can be in the form of rectangle also. It can be in the form of rectangle. Just now I told you, it should change the direction. It may be any form, plus, minus, plus, minus, plus, minus. It may be in the form of triangle also, if you want. It may be in the form of triangle or sawtooth. Okay? It may be in the form of triangle or sawtooth. Rampam type anamata. Okay na? You can see here, plus, minus, plus, minus, plus, minus. Continuously increasing and decreasing. Increasing, decreasing, increasing, decreasing. So these type of currents are called as alternating currents. That means periodically, if there is change in the direction, okay, or increase and decrease, periodically you can see plus, minus, plus, minus, plus, minus. Such a current is called as alternating current. Okay, periodically there is a change in the direction. Okay, if the direction is not changed, for example, you can see direct current, you can see this is a direct current, this is also direct current, this is axis, x-axis, y-axis. Okay, so you can see here there is no change in the direction of current. There is no change direction. You can see continuously it is. So this is a direct current. Okay, and if you observe carefully, see, this is also direct current. All positives, you can see, all positives. All positives. So such type of currents are always called as direct currents, please. Okay. So here periodically if it is increasing and decreasing, periodically if it is increasing and decreasing, such a current is called as alternating current. It may be any form, square, rectangle, triangle, sawtooth or sinusoidal curve. If it is not changing the direction, it is not changing the direction, that is called as direct current. Here if you observe carefully, this is origin, this is starting point, this is ending point. This is one cycle. Again starting, ending. 2 cycles. So this is a complete cycle. This is half cycle, T by 2. Okay? Like this you can name it. Okay na? So 0 ki T ki madhyalo enta undi, T by 2. You can also find here also half. 0 ki T half, T by 4 avutundi. This will become suddenly T by 4. T by 4. Here also you can find again. Okay? Here in enta avutundi half. You can T by 4. T by 4 plus T by 4. T by 2. T by 2 plus T by 4. 3T by 4. So like that you can also plot the graph. So here you can observe all these are alternating diagrams. And this is direct. Sometimes it will be confusing in this fashion also. See. Suppose if the graph is given in this fashion. Here you observe carefully. What is happening? See, the amplitude is gradually decreasing. When amplitude is gradually decreasing, again it may be you think that plus and minus. Plus and minus is there, but it is not alternating current. It is not alternating current. You can see the amplitude is decreasing continuously. Amplitude should maintain constant, plus minus. So this is again not an AC current. This is not an AC. Clear? So periodically if there is increase or decrease in the currents, that is called as alternating current. If it is not changing the direction, okay, then it is called as a direct current, please. So in this examination, questions are coming from MSET and NEET. Please make a note of this one. Regular questions are coming from this chapter. And in this chapter, you may expect 1 or 2 marks in MSET. 1 or 2 marks in MSET. Now, let us go for some more things. Let us learn. That is, see here. Here you have to know the point now. What is average current? I average. Okay. See, generally what is the definition of average? In general, in mathematics, average means, for example, 4 people are there. If anybody asks you what is the average weight of the 4 people, means what will you say? W1 plus W2, W3, W4 by 4 you divide it. Then that will be the average weight of the 4 persons. In the same way, average current and allows I1 plus I2 plus I3 plus dot 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 In divided by number n. If n currents are there, add up all those, divide by n. That is the average current. Another way of expressing in the form of sine. This is general form. Suppose I is equal to I0 into sine omega t. So here what is happening? I is changing with the time in sine function. I is changing with the time sine function. In such cases, how you will get I average? See, I average you can express in this way, or like this, or even like this. Are you following the point? Average anything you can write in this way, or bar, or like this. Clear? Now let us find an expression for I average current. If you do one thing, you can also find E average and also V average. ఒకటి వస్తే మీకు మిగతావన్నీ వచ్చేస్తాయి, క్యాలిక్యులేట్ చేయవసరం లేదు. If you calculate one current average, you will get voltage average, you will get EMF average also value. Okay na? Let us see. So what is the equation of current? I is equal to I0 sin omega t. ఇక్కడ omega t అనేది యాంగిల్ theta. Omega t అనేది యాంగిల్ theta. Theta is equal to omega t. Please make a note. Now with time, this value of current is changing. Now how to get I average for a full cycle? Okay, for a full cycle. Just now I told you what is a full cycle. See, this is the diagram, sine curve. So here if you observe, this is 0, full cycle. Okay, so this is half cycle, t by 2. దీంట్లో మళ్ళీ half ఇది. Okay na? T by 4. So like that you can get it. So full cycle means 0 to t time. So to get that one, just integrate it, you will get it. Okay, మీకు తెలుసు already physics లో చాలా వరకు. Suppose I is on y axis, t is on x axis. So how you will get the curve if you are having any curve? Area under the curve. Area under the curve is nothing but whatever. Suppose you are getting like this. Okay, so area under this curve, I dt. Okay na? Area I versus t ఒక గ్రాఫ్ వచ్చినప్పుడు ఇది ఎలా వస్తుంది? either by integrating or area under this curve. Okay na? Now what I will do is I'll try to integrate. So what is the function here? I is equal to I0 sin omega t dt integral full cycle ఇది 0 to t by integral 0 to t dt. So this is I average. How will you get I average? Integral 0 to capital T, because full cycle it is. This is full cycle. ఇదేంటిది? Full cycle. So I0 sin omega dt by 0 to t. ఇది ఎలా చేస్తారు? See, take I0 constant outside, integral 0 to t sin omega t dt by integral dt and t limits 0 to t, because it's a full cycle. Okay, full cycle limits vary, half cycle limits vary for the sine function. So here if you integrate it, I average is equal to I naught outside. What is the sin integral derivative of sin x is cos x, but integration is minus cos x. Integration is minus cos theta by this one angle, okay, by omega. This is how you have to do integration, okay, by this one. Limits enti 0 to capital T whole by ikkada t already have kept, upper limit minus lower limit, okay. So again I0 into, ఇక్కడ ఏమో మైనస్ ఉంది కదా, I'll take it outside, minus omega also I'll take it outside, and inside what is there, cos omega t. So cos omega t లో first upper limit minus lower limit, so I'll put it upper limit cos omega also I'll write, change is 2 pi by t, upper limit in the place of small t, okay, minus lower limit in this small t. ఇక్కడ 0 t ప్లస్ లో 0 పెడితే ఎంత, cos 0 1. Lower limit if you put in the place of t 0, 0 into omega 0, so cos 0 ఎంత 1 by t. Now continue, minus I0 by omega కూడా చేంజ్ చేస్తాను, 2 pi by t or pi కి t వెళ్ళిపోతుంది, into t gets cancelled. What is cos 2 pi? Cos 2 pi and the cos 360. Cos 2 pi and the pi into 180 into cos 360. Cos 360 అంటే ఎలా రాయొచ్చు, cos 270 plus 90, first quadrant, second quadrant, 180 plus theta, 180 plus theta, third quadrant, 270 plus theta, fourth quadrant. Fourth quadrant cos ఏంటి, cos 270 plus theta sin theta, that is sin 90. And cos is of course cos theta and secant theta are positive here, so plus sin 90, and ఎంత అవుతుంది sin 90, 1. So 1 minus 1, what is the value, 0. 0 into this thing, even though if you have down denominator t also, 0 into this thing how much, 0. Clear? Therefore I average for full cycle 0. Adotna? So this is the how you got by integrating. See some books they are giving directly the value, because to understand better manner I have derived for you. So I average either bar or like this, or I average is equal to how much, 0. For full cycle it is 0 value. Now let us calculate for half cycle. ఏమవుతుందో same thing, please copy it. Same thing, half cycle అంటే ఏం లేదు, లిమిట్స్ మారుతుంది. లిమిట్స్ ఏంటి, 0 to 2 bit. See for half cycle లిమిట్స్ ఏంటి, 0 to 2 t by 2 ఉంటుంది, అంతే, మిగతా అంతే ఏం లేదు. Just I'll change the limits, remaining all I'll keep it like that, okay. So for full cycle what is the value, 0. Full cycle value ఏమొచ్చింది, 0. Now let us go for half cycle value. Limits మారుస్తున్నాను, I am changing the limits. I am changing the limits for half cycle. I'll change the limits please. Half cycle remaining all will be same, only I am changing the limits please, okay na. I'll change the limits. Clear? So half cycle I average is equal to half cycle kide. Half cycle for full cycle it is 0, already clear. Half cycle limits enti, 0 to t by 2, 0 to t by 2, 0 to t by 2, all the things will change. Remaining అంతా బాగానే ఉంటుంది. ఇక్కడ ఏంటి, 0 to t by 2, that means upper limit minus lower అంటే ఇక్కడ t by 2, okay na. And here 0 to t by 2, okay. Here ఏమవుతుంది చూడండి, మారుతుంది వాల్యూ. Here also I am changing the limits. I am rubbing this last step. I will rub the last step, that is better. So if you apply 0 to t by 2 here, what happens here, same thing, it will come outside minus I0 by omega, okay, 2 pi by t, this value, and t plus లో ఏం చేయాలి, t by 2, upper limit ఏంటి, t by 2. Again here what happens, ఇక్కడ ఏమవుతుంది మనకి, lower limit is 0 again, lower limit is 0. సో 0 పెడితే ఆ t ప్లస్ లో మళ్ళీ ఏమవుతుంది, cos 0 1 ఇక్కడ వస్తుంది. And down what will happen? Upper limit t by 2 minus 0. Okay? Up to here clear? Now I'll rub this part for understanding better manner for half cycle. Okay? So in half cycle now we are having the values as, otherwise it will go wrong. I0 by omega, again I'll change it as 2 pi by t. T goes to the top. Inside 2 gets cancelled. T gets cancelled. Cos pi. What is cos pi? 180 degree minus 1. That minus 1, again minus 1, minus 2. I'll write it here. Minus 1, minus 1. And down what you are having here? Upper limit minus 2, that is t by 2. Okay. Now here what happened? Minus 1, minus 2, and minus 2. That minus 2 into this thing, plus 2. So 2I0 t by 2 pi, t by 2, only 2 pi keltundi. T will come here. T, 2, 2. So what is the answer? 2I0 by pi. So this is the I average for half cycle. Please put it in your mind. For full cycle, put it in your mind. For full cycle, 0. And half cycle value and the I average like this or like this or like this is given by 2I0 by pi. If you want EMF, E average is given by 2E0 by pi. If you want voltage, V average, half cycle, 2V0 by pi. So please remember these values, very important bit questions. The average current for full cycle is 0, half cycle values 2I0 by pi, 2E0 by pi, 2V0 by pi. Clear? Right. So please note down. Now let us go after copying this one, RMS. How to get RMS value, please? Okay? Root mean square value. Root mean square value. Clear? So finally we got the values I am writing here. For half cycle, I average is equal to 2I0 by pi. Alage E average, EMF, 2E0 by pi. Alage V average is equal to V0 by pi. These values you have to put in your mind for half cycle. Now we will go for what is IRMS. Root mean square value. So ikkada ee point lo undi RMS. You have to go in reverse order. Square, mean, root. Okay? So what is the function? You know, I is equal to what? I0 sin omega t. First what you have to do? You have to square. So I square is equal to I naught square sin square omega t. Next mean, root, okay? So first angel square, then mean, okay? Then square root. So RMS means don't go like this, in reverse order you have to go. Root means square, but square, mean, root. Now we will find the value for this one. Okay, mathematically I will find the value. See what happens here. I square. So for this I want RMS value now. IRMS is equal to I naught square sin square omega t. Now let us put this one left side. Constant. ఇక్కడ లిమిట్స్ ఏంటి? సపోజ్ ఫుల్ సైకిల్ తీసుకున్నాం అనుకోండి. ఫుల్ సైకిల్ ఎంత వస్తుంది ఇక్కడ మళ్ళీని? ఇది కూడా 0 వస్తుంది. ఓకే, ఫుల్ సైకిల్ ఇస్ 0. హాఫ్ సైకిల్కే వాల్యూ ఉంటుంది మీకు. లెట్ us ట్రై వన్స్ అగైన్ ఫుల్ సైకిల్ ఏమవుతుంది. ఓకే, సో IRMS is equal to full cycle. Same ఇందాకలాగే let us go for full cycle. I average for full cycle was 0. Half cycle is 2I0 by pi. అలాగే 2E0 by pi. E average. అలాగే V average, voltage average equal to 2V0 by pi. So in the same fashion we will calculate for RMS value for full cycle. So full cycle and limits ఏం చెప్పాను? 0 to t by integral 0 to t dt. So this will become what? Constant బయట తీసేయండి. Sin square theta in trigonometry I can write 1 minus cos 2 theta by 2. In trigonometry, sin square theta I can write as, here see, sin square theta I can write as 1 minus cos 2 theta by 2. Okay? So ఆ విధంగా రాసుకున్నాను ఇది. Now I'll integrate this one. Kinda as it is again, 0 to t dt. So constant బయటకు వచ్చిన దీనికి ఇంటిగ్రేషన్ చేయాలి ఇప్పుడు మనం. 0 to t dt. Clear? Okay? Now I'll extend the thing, derivation, I naught square. Okay? Here what I'll do, 2 బయటికి తీసుకెళ్ళిపోదామా? 2. We'll take outside 2. Okay? By 2 కదా, I'll take it outside 2. 2 బయట తీసుకొచ్చాను. ఇక్కడ ఏం మిగిలింది మనకి లోపల? ఇంటిగ్రేషన్ ఇంకా చేయలేదు మనం, బికాజ్ యూ జస్ట్ చేంజ్ ద ఫార్ములా. యూ హ్యావ్ టు డూ ఇంటిగ్రేషన్. సో ఫస్ట్ 2 బయట తీసుకొచ్చాను, పైన dt 1 into t dt. ఓకే, ఇంటిగ్రల్ 0 to t, ఓకేనా, బ్రాకెట్ మైనస్ 2 I have taken outside. Cos theta, derivative of cos theta is minus sin theta, but integration sin. Okay, cos theta derivative into minus sin, but integration is sin. So sin theta, that is by integration కాబట్టి this value you have to put down omega. Okay, na minus అలాగే ఉంటుంది. And limits 0 to t full cycle కదా, ఇదంతా బ్రాకెట్లో, ఇదంతా బ్రాకెట్లో. ఓకే, నా డినామినేటర్ అగైన్ dt t, that is small t, limits 0 to capital T. Clear? Note it down. I'll rub the first step better. So you are calculating IRMS value for full cycle. We know the value, but still for understanding better manner I am doing for you. So ఏమైంది ఇక్కడ మనకి, జాగ్రత్త ఎక్స్టెండ్ చేద్దాం. I left over with I square by 2 inside. ఇక్కడ చూడండి dt ఇంటిగ్రేషన్ ఎంత, t లిమిట్స్ ఏంటి, 0 to full cycle, minus here what I'll do, I'll take 2 omega outside better. 1 by 2 omega అంటే omega means 2 pi by t again. T I'll take it to the top into t plus లో upper limit, see here, sin 2 into omega, that is 2 pi by t into upper limit t minus lower limit sin 0 0, sin 0 0. This is numerator. Denominator value ఎంత వచ్చింది, upper minus lower. ఇక్కడ వరకు ఓకే కదా. Now I am rubbing this step also, please. I am rubbing this step also for convenience of you. Okay, so finally I am having, we'll see what happens finally. So I am extending I square by 2 into upper limit capital T minus 0, that is t, minus ఇక్కడ t by 2 2s are 4 pi, of course, bracket. ఇక్కడ చూడండి t క్యాన్సిల్ అయిపోయింది, ఇది sin 4 pi అయింది, ఇది ఆల్రెడీ 0. సో వాట్ ఈజ్ sin 4 pi అంటే sin 2 into 2 pi, యాక్చువల్గా ఇది ఇంటిగ్రల్ మల్టిపుల్ ఆఫ్ దిస్ యాంగిల్ అంటే 360. sin 2 in n into 360. What is sin 360? Sin 270 plus 90 అంటే cos 90 మళ్ళీ ఎంత, 0. అదొక cos 90 0. సో 0 minus 0 and 0 into this function again. మీకు అర్థమైంది ఇక్కడ sin 360 means sin 270 plus 90, fourth quadrant, cos 90 0. So this entire thing becomes 0. And 0 into this thing again be 0. And denominator లో ఇంకెంత ఉంది, t మిగిలింది. So what is left over now? I square by 2, ఈ లోపల you are having t and denominator t cancel. Okay, now what is left over? I square RMS kada for full cycle is equal to I0 square by 2. ఇదంతా 0 కాబట్టి క్యాన్సిల్ అయిపోయింది, 0 into this thing. Now what is IRMS for full cycle? root over I0 square by 2, that is I0 square and the I0 by root 2. This is the value. Clear? So RMS value you are getting as I0 by, okay, root 2 value. Please check it. Very important. Very important is for full cycle we got the value as I0 by root 2. Any doubts, please? Any doubts? Any doubts you can ask me. So here we have taken the limits as usual, 0 to capital T. This entire function gone 0, and finally we are left over with I0 by root 2. In the same way, if you ask the EMF also, ERMS, okay, E0 by root 2. Alage VRMS, if they ask, voltage RMS, V0 by root 2. Oka value kadte, all the values are same. Clear? Any doubts? Okay, clear? Right. So this is how you have to calculate. So applying the limits, using little mathematics, and finally finding the value. Just to explain, I am deriving actually, otherwise I would have given direct values for you. So RMS values finally we got RMS as I0 by root 2, VRMS V0 by root 2, okay, and ERMS E0 by root 2, please. Okay, clear? Right. So this is how the RMS value is found out. So IRMS I0 by root 2, VRMS V0 by root 2, ERMS E0 by root 2. In the same way for full cycle I average, how much you got? 0. For half cycle I average 2 by pi I0. Alage V 2 E0 by pi E. Alage V 2 V0 by pi. So please remember these values, whatever you have derived. Okay, these will be useful in the examination point of view, please. Clear? Now let us enter into the pure resistor circuit. Let us enter into the pure resistor circuit, please. Pure resistor circuit. Let us enter into pure resistor circuit. Now what is pure resistor circuit? See, in the circuit only resistance is there and alternating current voltage, that is V is equal to V0 sin omega t. So let us see, current is going, and if you apply KVL, Kirchhoff's voltage law, so what happened here? V minus potential same direction, potential drop, that is IR is equal to 0, or V is equal to IR. But what is V? V0 sin omega t is equal to IR, or V0 by R sin omega t is equal to I. So what is current here? But here if you observe carefully, V0 by R is nothing but I0, peak value of current. So therefore what happens here? I is equal to I0 into sin omega t. Same way V is equal to V0 into sin omega t. Is there any phase difference? No phase difference. You can see nothing is a minus or plus. Therefore in this case 5 is equal to 0. Phase difference is equal to 0. That means where the current is there, voltage is also in same direction. Phase difference is 0 between voltage and current. Current ఎటువైపు ఉందో voltage కూడా అటువైపు ఉంది. Clear? Right. Now I will try to explain for this one phasor diagram. Please note down. Right. Now for this one, how to write phasor diagram? I mean draw phasor diagram. Very important. See, phasor diagram is very important. Phasor diagram. See, this is actually pseudo vectors we are using here. Pseudo vectors, not real vectors. as EMF and voltage and current, really those are scalar quantities. But here we will be rotating them and assuming as a pseudo vectors. ఒకసారి చూద్దాం ఏంటి అనేది. See here, I'll drop this also so that the diagram will be better for you. Phasor diagram. So phasor diagram ఎలా అంటే చూడండి. So this is okay. Now ఇక్కడ ఏమైంది, ఫేజ్ డిఫరెన్స్ రెండింటి మీద 0 అంటే కరెంట్ ఎటువైపు ఉందో, ఫర్ ఎగ్జాంపుల్ సి వాట్ ఈస్ వోల్టేజ్, V is equal to V0 sin omega t. This is voltage. Okay, what is the angle? Omega t. What is omega? Omega t is the angle, sin omega t. In the same way, what is current? Current is also I0 sin omega t. So it is also where? Down or top? Same direction. So ఎక్కడైతే వోల్టేజ్ ఉందో కరెంట్ కూడా అక్కడే ఉంది. Where you are having voltage, current is also same direction because phase difference is 0. Now we will rotate this one. Now we will rotate in anti-clockwise. This is phasor diagram. We will rotate now. See? Very, very important. And I will extend the graph. I will extend the graph. This is origin. For example, this is say pi by 2, pi, 3 pi by 2, that is 2 pi. And then 90 degrees, 180 degrees, 270, 360 degrees. Okay? Just I am making to understand the phasor diagram, each and everything, so that you can get the concept very easily, please. Are you understanding? Now see, this is the maximum value voltage, and here maximum value of the voltage. Here is the maximum voltage. Okay? Now what is voltage? V is equal to V0 sin omega t. So put for sin 0 angle. In the sin theta put sin 0. Sin 0 is 0. Okay? For voltage. Next put 90, sin 90, 1, maximum value. Maximum value. Again sin 180, again 0. Okay? Next sin 270, again minus 1. Minus 1. Again sin 360, 0. So this is the graph for voltage. అర్థమవుతుంది మీకు? sin 270 తెలుసు కదా, sin 270. 180 plus 90. ఓకేనా? థర్డ్ క్వాడ్రంట్ సైన్ ఇస్ నెగిటివ్, అందుకే అలా మళ్ళీ sin 360, 270 plus 90, cos 90, 0. Same way if you draw for current also, same thing again, 0, but the graph will be peak little lesser. Same way for current, same way. Okay, this is the value you can see. Maximum 0, minus 1, this one, again 0. So these are the graphs for current and voltage phasor diagram for pure resistor. Please try to understand the concept. Concept is where, because we are rotating in anti-clockwise, these are pseudo vectors. Actually these are scalar quantities, but here we are using it as a pseudo vectors. Clear? Right. Now let us go to pure inductor. This is pure resistor. Okay. Now I am going to pure inductor. We'll see what happens in this case. Pure inductor lo ఏమవుతుందో చూద్దాం. Phasor diagram, rotating vector, etc. Try to understand this concept. Concept is very much important. They are asking the examination. ఇప్పుడు నెక్స్ట్ ఏంటంటే ప్యూర్ ఇండక్టర్. ప్యూర్ రెసిస్టర్ అయిపోయింది కదా. ప్యూర్ ఇండక్టర్ ప్లీజ్. Pure inductor. L. So that means see the diagram, circuit diagram. pure inductor. Here the voltage, alternating voltage V is equal to V0 sin omega L. Okay, L means here minus L dI by dt, inductor kabatti. Again apply KVL here. Again drop as V minus L into dI by dt is equal to 0, or V is equal to L into dI by dt. Applying Kirchhoff's voltage law. But what is V here again? V0 into sin omega t into dt is equal to L di. Okay. Now what I want current here. So to get current, what I have to do? I have to integrate it. I have to integrate it. Then I will get current. So here what I will change this one to this side. L di integral is equal to integral V0 sin omega t dt. L is constant for di. I is equal to V0, take constant outside, integral of sin theta. Sin theta is cos theta actually, but it is minus cos integration kabatti. So minus cos omega t by angle omega. So therefore ఏమైంది ఫైనల్ గా I is equal to ఇది బయట తీసుకొచ్చేయండి V0 by L omega. Of course minus is there, cos omega t. Observe carefully, this is what peak value. Here I0 is equal to V0 by omega L. What is omega L here? Omega L is called as XL, inductive reactance. This is also resistance. This is also equal to resistance. Units called ohms. But here the terminology you have to use is inductive resistance, reactance. Into the inductive reactance. In next case we'll be saying inductive capacitance there. So here XL means it is also resistance, but when in the circuit inductor is used, then the name is changed as inductive reactance. Okay, inductive reactance. So ఇక్కడ దీన్ని మనం ఇలా రాసుకోవచ్చు V0 by XL, maximum value. But if you observe carefully, here negative value is coming. So how cos theta minus cos theta can be written in trigonometry? Sin of theta minus pi by 2, or you can also write sin of omega t minus pi by 2. Then you can change into minus. This is equal to minus cos theta minus omega t. ఎలా చూడండి, multiply and divide with minus 1. When minus 1 goes to sin 90 minus theta cos theta, కింద మళ్ళీ మైనస్ ఉంటుంది. So minus omega t. So this one you can write in this form, sin omega t minus pi by 2. Please copy it. Copy the equation. Right. So I am writing the equation, final equation now. What is the final equation? So current I am writing as I is equal to, okay, sin omega t minus pi by 2. And I naught value is nothing but this one. Okay, I naught value, what are peak value? See, I naught ఇక్కడ ఎంత వచ్చింది మనకి, V0 by XL, inductive reactance. This is also resistance. So here what is happening, you can see now, V is equal to V0 sin omega t, and current is what? Lagging. Current is lagging by, you can see, current is lagging by 90 degrees or pi by 2. In this case what happens? Current is lagging by pi by 2. This is original equation. I is equal to minus V0 by omega L cos omega t. But if you change into sin function, you can write in this fashion, sin omega t minus pi by 2. Multiply and divide with minus 1, you get cos theta there, minus cos theta. So again for this also you can draw the phasor diagram. Right. So for this one I will copy it. Right, I am dropping this figure. So phasor diagram if you draw for this one, same thing you are getting. I will drop this also better because I don't have place. Omega t minus pi by 2. See, once again. So current, voltage. So this one is voltage. Okay, how much angle it is making? omega t, because V is equal to V0 sin omega t. Now what is happening to the current? I is equal to I0 into sin omega t minus pi by 2. So minus and ekkada lagging. So this is current. You can see it is lagging by how much? Pi by 2, 90 degrees. Current is lagging. This is leading. So now again rotate this one. Rotate. And this also rotate. Extend the diagram. Phasor diagram. 0. Origin. 90 pi by 2. Pi 180 degrees. 270 and 2 pi 360 degrees. Again same thing, graphs. Clear? So what happens here? Again maximum value for voltage. Here maximum value for voltage. So again put the value sin 0, same you are getting. Okay, maximum, minimum, maximum 270 again negative value, again 360 0. Now coming to here you can see what is minus cos theta. And the minus cos theta enti, suppose if you put 0 here, 0, cos 0 and the 1, and here minus is there and the minus 1, and I can start on the graph. It won't start from here, it will start from here. This is the peak value. This is the peak value of current. So it starts from minus 1. Ekkadi nunchi ikkadi start avutundi. Because cos 0 is 1 and minus 1 ikkadi start avutundi. Then the cos 90 0. Next cos 180 minus 1, minus into minus plus again. It will come here. Again cos 270. 270 and then the 180 plus 90 cos 90 mali 0. Again cos 360. So cos 270 plus 90 sin 90. Okay na? And sin 90 ikkada enti avutundi okasari chudandi. Negative value, fourth quadrant. One negative value, positive value. But here minus is there, so minus. Okay, this is the graph. So like this, the graph is coming for the phasor diagram for this one, sin omega t minus pi by 2. Be careful, it will start from down, minus kabatti. Again cos 90 0, 180 plus 1 again. Again 270 0. Again 360 and 270 plus 90. 270 and fourth quadrant. That is 270 plus fourth quadrant sin 90. Of course positive, but here minus is there. So minus. So this is how the rotating vector diagram is for pure inductor. So please make a note in inductor, current is lagging by pi by 2. Current is lagging by pi by 2. Very, very important in the examination. We are asking current is lagging by pi by 2, please. Clear? In the same way you can draw for the other also, you can try at home. Okay? In the same way you can try for the other one. I will directly give the value. Because for explanation purpose I have drawn for you. Remaining I will directly give for you. Next one enti pure capacitor. That you can try at home. Pure capacitor. Second one, pure capacitor. So this is the circuit diagram for pure capacitor. This is alternating voltage. V is equal to V0 sin omega t. Okay. Q by C is equal to V, or Q is equal to CV. Okay. Now applying again KVL. So what happens? V minus Q by C is equal to 0. Why have written Q by C? What is the voltage here? Q is equal to CV kada. So Q by C. So again V is equal to Q by C. But what is V? V0 sin omega t is equal to Q by C. Okay? Or V0C into sin omega t is equal to Q. But how to get I derivative? So dQ by dt is equal to d by dt of this function v0c sin omega t. dq by dt means current I, derivative of this thing v0 sin, derivative of sin x and the cos x. So cos omega t into omega. So what is the final value current? I is equal to v0 omega c cos omega t. Once again here indaka minus cos theta vachindi, ikkada plus cos theta. So how to write plus cos theta? Simply I can write as sin omega t plus pi by 2. Sin 90 plus theta, second quadrant, cos theta. And sin is positive in second quadrant. So you can write in this fashion. So current I can write as I is equal to I0 into sin omega t plus pi by 2. What is voltage? Sin omega t. So current ikkada em current is leading by how much? 90 degrees, pi by 2 in pure capacitor. In pure inductor, current is lagging by pi by 2. Very, very important. So this is what final I0. You can see here. What is peak value? I0 is equal to V0 into omega c, or I can write like this. I0 is equal to V0 by 1 by omega c I can write. Enduku 1 by omega c, right? Omega c will go to the top. So this is nothing but what? V0 by XC. Capacitive reactance, this one. Inductive reactance. Here XC is again another resistance called as capacitive reactance. This is also equal to resistance when the circuit is connected with a pure capacitor and alternating voltage. Indaka man inductor lo inductive reactance vachindi XL, but here 1 by omega c is equal to XC. This is called as capacitive reactance. Clear? So దీని కూడా మీరు you try at home the phasor diagram. Here it will be leading pi by 2. Graph కొంచెం different ఉంటుంది. దీని graph okay, same thing. But here what happens? The graph will be you can see here omega t plus pi by 2. Omega t plus pi by 2. అంటే కొంచెం graph మారుతుంది. You can take the same value, but only thing is it is leading. Angle అంతా leading by pi by 2. Graph అయితే సేమ్ వస్తుంది. చూడండి ఇది value. Put 0, cos 0. Okay? Cos 0 and the 1 starting with that point. Again 90, cos 90 0. 0 అయిపోతుంది. Again 180 minus 1. Okay? Right. Now I am drawing the phasor diagram for this one, please. Copy it. Okay. So same thing you can draw for this one, nothing to worry at all. Rotating vector, you అలా వేసుకొని you can draw like this. Voltage V0 omega t, and here what happened? Current is leading by pi by 2. So ikkada vasthundi. Back side kada front. It will go like this. I0. It is leading by pi by 2. So rotating vector malli will draw the figure like this, and this also will draw like this. Again the graph will be going like this. Maximum and minimum. Okay? Again sin 0, you will get the graph. That's the point. Same thing again. Clear? Right. So this is how you have to understand the concept. Pure inductor, current is lagging by pi by 2. Pure capacitor, current is leading by pi by 2. Very, very important these phasor diagrams, because in numericals these are coming nowadays. You have to solve that one. అర్థమవుతుంది మీకు? సో ప్యూర్ ఇండక్టర్ అయిపోయింది, ప్యూర్ కెపాసిటర్ కూడా అయిపోయింది. ఓకే, ఇండక్టర్ అయిపోయింది, రెసిస్టెన్స్ కూడా అయిపోయింది, ప్యూర్ రెసిస్టర్ అయిపోయింది, ప్యూర్ కెపాసిటర్. సో వాట్ ఈస్ ద థింగ్ మెయిన్లీ హియర్? ఇన్ ప్యూర్ రెసిస్టెన్స్ వేర్ ఈస్ ద కరెంట్? Voltage also same direction. But in inductor what happened? Inductor, if you observe carefully, current is lagging by pi by 2. I is lags by pi by 2. అర్థమవుతుంది మీకు? అంటే మీకు పైన వస్తుంది ఇక్కడ. Here the voltage, inductor. So you can see current. Current is lagging by pi by 2. Pure capacitor ఏమైంది? ఇక్కడ VC వస్తుంది, ఇది కరెంట్. So what happened? Current is lagging, ఇక్కడ లీడింగ్, ఇక్కడ లాగింగ్ అని చూడండి, ఇక్కడ లాగింగ్, వోల్టేజ్ ఇస్ ఫ్రంట్. ఇక్కడ ఏమవుతుంది? కరెంట్ ఈజ్ లీడింగ్ బై pi by 2. In capacitor, current is leading by pi by 2. VC will be down. In the same way you can draw for the XL and VC also. చూడండి, resistance same direction, pure resistor, current is also in the same direction. Phase difference is 0. But pure inductor ఏమైంది? Current, resistance same direction, inductor, that is XL, will be in this direction. అదవుతుంది మీకు పాయింట్ ఇక్కడ when pure inductor ఉన్నప్పుడు ఏమైంది? I is lagging. సో అప్పుడు ఏమవుతుంది మనకి? కొత్త లెటర్ ఒకటి వస్తుంది మనకి, that is called as impedance Z. Let this be 5. So what is impedance? Impedance is also resistance. But when a resistor, when a inductor or a capacitance is connected in the circuit, this impedance will come into picture. So here what is Z here? How to get Z? Root over XL square plus R square impedance value. The same way, what is tan phi here? Direction opposite by this, that is XL by R. And what about this case? In capacitor, the impedance root over XC square plus R square. And what is tan phi in this case? Tan phi opposite, that is XC by R. So these things you have to put in your mind. Very important. Very important ఇవి. ఎందుకంటే ఫ్యూచర్లో ప్రాబ్లం చేస్తున్నప్పుడు ఇవి బాగా మనకి యూజ్ అవుతాయి. Have you note down? Right. Now after this one, we have completed pure resistor, pure inductor, okay, and pure capacitor. Inductor current is lagging by pi by 2, capacitor current is leading by pi by 2. Okay. So these are very important things. Very important things. Now we are left over with some more half concept is left over. That is now combinations. Next is combinations. Combinations and ending. Next are combinations. Combinations means LR, CR like that. Okay. First is RC. Series connection. RC series connection. RC means what? Resistance, capacitor. Okay na? Alternating voltage. Okay na? The same way LR CR series circuit. LR and enti? Inductor and resistance. Alternating voltage. V is equal to V0 into sin omega t. ఇక్కడ కూడా capacitance, resistance, RC, LR. Okay? So V is equal to V0 into sin omega t. ఇంకేముంది మన కాంబినేషన్? CR, CL, LC. ఓకే, LC కూడా తీసుకోవచ్చు మీరు. LC థర్డ్ కాంబినేషన్. ఓకే, సో V is equal to V0 sin omega t. So these are the permutation combination: RC circuit series, LR series and LC. So for all these again you can apply and you can get the equations also by KVL. So in this case if you draw phasor diagram, capacitance and చూడండి resistance ఉంది, capacitance. Resistance ఏమవుతుంది? Same direction current, voltage కూడా same direction resistance లో. కెపాసిటర్ ఉన్నప్పుడు ఏమవుతుంది? కెపాసిటర్ ఉన్నప్పుడు ఏమవుతుంది? కరెంట్ ఈజ్ లీడింగ్ బై పై బై 2. ఓకే, సో హియర్ కరెంట్ టు రెసిస్టెన్స్ సేమ్ డైరెక్షన్, voltage same direction, but what happens here? Current is leading by pi by 2 with this one. Same thing diagram you can draw for resistance. This is XC. Okay, what happens with impedance? Root over XC square plus R square, angle phi, that is tan phi, is equal to opposite by its end, XC by R. Okay na? So ikkada capacitor resistance unte emundi chudandi, current is leading by pi by 2. So this is the resultant value. Tan phi is equal to opposite by its end, XC by R. Clear? The same voltage కూడా ఏమవుతుంది? voltage ఏమవుతుంది? resultant voltage V net is equal to root over Vc square plus Vr square by using parallelogram law. Coming to here, resistance current ఎటువైపు ఉంటుందో resistance అటువైపే, inductor VL పైకి pi by 2. So this is net, V net. So V net is equal to root over VL square plus VR square. Because here what happened, inductor current is lagging. Current is lagging by pi by 2 with voltage. Here current is leading by pi by 2. So the same if we draw the resistance diagram also, what happens? XL. So this is impedance phi. So root over XL square plus R square. Same way tan phi is equal to opposite by adjacent. Is R. Clear? Now coming to here, ఇదేమవుతుంది చూడండి కాంబినేషను. ఇక్కడ ఇండక్టర్ కెపాసిటెన్స్ అంటే ఇదిగోండి, ఇది మనం తీసుకోవాల్సిన జస్ట్ ఫర్ ఫన్ ఐమ్ టేకింగ్ రెసిస్టెన్స్ అండ్ వోల్టేజ్ సేమ్ డైరెక్షన్. సో దిస్ ఈజ్ వాట్ VL అండ్ దిస్ ఈజ్ VC. సో ఇక్కడ రెండు కండిషన్స్ ఉంటాయండి. రెండు కండిషన్ ఏంటంటే, ఫస్ట్ వన్, సపోజ్ VL is greater than VC, voltage in the inductor is greater. Second case, if VL is less than VC. Third case, if VL is equal to VC. In the same way, if XL is greater than XC, if XL is less than XC, that is inductive resistance, inductive reactance is greater than capacitive reactance, and inductive reactance is less than capacitive reactance, and last case, if XL is equal to XC. ఇవన్నీ కాంబినేషన్స్ మనం ఇక్కడ స్టడీ చేస్తాం. క్లియర్? రైట్. నా సపోజ్ చూడండి ఇక్కడ, సపోజ్ ఫస్ట్ కేస్ చూద్దాం. ఇఫ్ VL is greater than VC, then the resultant will be in that direction. అప్పుడు ఎంత అవుతుంది? దిస్ ఈజ్ R or VR. రిజల్టెంట్ అని ఇటువైపు ఉంటుంది. సో VL minus VC. And the net, this is V net, root over VL minus VC whole square plus VR square. The same way, resistance XL greater kada, XL minus XC. Net ఎంత అవుతుంది impedance? Impedance is equal to root over XL minus XC whole square plus R square. Second condition, if this is greater, అప్పుడు డయాగ్రామ్ మారిపోతుంది. R, that is VR, comes down, that is VC, then this will be V net. So V net ఎంత అవుతుంది? If this is greater, VC minus VL. So root over VC minus VL whole square plus VR square. In the same way, this is R and this is XC. So this is impedance. Impedance is equal to root over, this is greater కదా XC. So XC minus XL whole square plus R square. ఇక్కడ రాస్తాను చూడండి క్లియర్గా. XC minus XL whole square plus R square under root. And again tan phi XC by R. So like this you can calculate if the values are greater. And the last case ఉండిపోయిందండి. Last case ఏంటంటే, if VC is equal to this thing, that is called as resonance condition. Last case ఏంటి? If VC, what voltage across capacitor is equal to voltage across inductor, then what happened? Phase difference is 0. Current and resistance will be in same direction. Current and resistance both are in same direction because these both are equal. Equal ఏమవుతుంది? This only the resistance. This is equal to what? Pure resistor. See, when voltage across capacitor and inductance are equal అయితే ఏమవుతుంది? అప్పుడు ఓన్లీ రెసిస్టర్ ఉంటుంది అనమాట. It is equal to pure resistor and the phase difference 0. This condition is called as resonance condition. Resonance condition. In the same way you can apply for the inductive reactance and capacitive reactance, please. చూడండి, the same thing can apply for the third condition for XL and XC. XL means that is inductive reactance is equal to capacitive reactance. Okay? Capacitive reactance is equal to resonance condition. So XL and into omega L is equal to X and into 1 by omega C. Or frequency, angular frequency, omega square is equal to 1 by LC inductor and capacitance, or omega is equal to root over 1 by LC, that is equal to 1 by root LC. This omega is angular frequency. Sometimes it is also written as 2 pi n or 2 pi f. F is frequency. 2 pi n or 2 pi f. కొంతమంది n follow అవుతారు, you can write n or f is equal to 1 by root LC, or f is equal to 1 by 2 pi and root over LC. So this is the frequency formula for resonance condition. And if the voltage of capacitance and inductance is equal, then it is equal to pure resistor. No phase difference, 0. Then XL is equal to XC. Then this is the formula. Okay, clear? So these formulas are very, very, very important for the numerical problems. We'll do one thing. Only half an hour or 1 hour class is left for another 40 minutes. Remaining part, that is power factor, formula and other thing, and also other graphs, and also last one, 3 combinations, LCR circuit series, that I will be dealing in the next coming class. Okay, that is in part 2 of alternating currents, right?